magnification for refraction at spherical surface. So suppose guys, if I have a spherical surface like this of a radius of curvature r, and suppose this is the principal axis, this is basically the pole, and let's say the object is over here, okay, and let's say one light ray is going like this straight, and the second light ray will be, let's pass it through the pole, and let's say here the image is drawn, right? This distance is basically u, this distance is basically v, and what do you need to find out? You need to find out, hello. Acha, by the way, this line will not be exact straight because the medium is changing now. Here the medium is mu1 and here the medium is mu2. So let's say light has changed its direction. So this angle is angle of incidence and this is angle of refraction. Can you see this light ray is basically one which is passing through the center, the principal axis, right? Yes or no? This is the principal axis. Hello guys, are
Yes,
you
sir.
able to hear me?
Yes,
Please
sir.
बोल तो दो यार, कुछ बोलते भी नहीं हो. So
Yes,
anyways,
sir.
we want to find out what is the magnification formula. First of all, we know by Snell's law mu1 into sin I will be equals to mu2 into sin R. By Snell's law, yeah, yes or no? So from here, can I
Yes.
say sin I by sin R is equals to mu2 by mu1? And if I say for paraxial incidence, if you want, for near normal incidence or paraxial incidence, can I say this particular thing sin I upon sin R will be approximated to tan I is to tan R as well, right? Can I use the small angle approximations over here? Yes or
Yes,
no?
sir.
And can you
Yes.
see two triangles over here? P, let's name the objects as A, B, and let's name the image as A dash, B dash. So can I say this particular thing? Tan of I is basically AB upon BP divided by tan of R A dash B dash divided by P, B dash B, right, is equals to mu2 by mu1. Can I see this? Now can you see over here, AB is basically the height of object, I'm using it with sign convention. A dash B dash is basically the height of image, I'm again using it with sign convention, it was down, right? And BP is basically the object distance to minus u. I'm using this convention guys, normal, uh, if I have not mentioned anything then I'll be using this normal apna Cartesian convention. And B dash P is basically plus Q. Yes or no? Shall I put it over here? Yes or no? Can I put it over here? So plus HO by, अच्छा इसको और I can solve it a little bit. I can write this as AB upon A dash B dash is equals to B into B dash B upon B. So AB is plus HO, A dash B dash is minus HI, B dash B is plus V, BP is minus U is equals to mu2 by mu1. And from here, do you remember this HI by HO? Guys, do you remember HI by HO? Magnification is basically what? HI by HO, right? So can I rearrange? HI will go over here, HO will go over here, mu1 will go over here, mu2 will go over here, minus and minus sign will get cancelled out, right? So it will be mu1 times of V divided by mu2 times of U. Can I write it like this? Will this be the final formula? Or can I rearrange this as mu1 upon V divided by mu2 upon V? Can I do this? Please write. Tell me to scroll up or down if you want. Can you see these two terms are similar to the formula mu2 by V and mu1 by U? Mu2 by V and mu1 by U. So don't remember this, remember this. Easy. Guys, is it clear?
Yes, sir.
Okay. So after this, let's do some numericals, and after that, you will leave one more page for J unit stuff in this refraction through spherical surface. Okay. Suppose uh, there is a glass sphere like this. This is a glass sphere of a radius 10 centimeter, and let us say this is the principal axis. So guys, can you see the question, right? So figure shows a glass sphere of radius 10 centimeter. Along its diameter, let's say AB, along its diameter AB, from one side of the sphere, a parallel beam of paraxial rays, a parallel beam of paraxial rays is incident on this surface, right? Now the question is, what should be the refractive index of glass so that after reflection or after refraction all rays converge at opposite end of a diameter, basically b point. So basically, what do you want, guys? What do you want in this question? Guys, what do you want in this question? You want the light rays to be incident where? You want the light rays to be incident at point A, on this surface AB, control C, control V, and you want these light rays to converge at point B. So everyone can understand exactly what we want, right? Chalo, try to do the question. So this is the incident rays, parallel incident rays on one of the surface, and you want the refracted rays to converge where? At point B on the opposite end of the diameter. This is what you want. So for that, what will be the value of mu? That is, you need to calculate. It's here. This is also here. See, basically, you need to just analyze data. First of all, tell me if the rays, incident rays, are parallel to each other, to where exactly is the object?
Infinity.
Infinity.
Infinity. The image shall be placed where? Image from this surface. Can you see the refraction is happening on this surface? So the pole will be at point A. You will consider every distance from point A. Now, tell me where is the image from?
10
10
centimeters.
centimeters.
10 centimeter radius है 10 centimeter.
Oh,
20.
20 then.
20 centimeter. And plus ki minus convention. Let's say here it is
Plus.
positive, here
Plus.
it is negative. Let's say minus infinity and plus 20. Is it clear? Now, what is the radius?
10
10 centimeter, and
10
plus ki minus?
centimeters. Plus.
Plus. Why plus? Because
Plus.
can you see the curvature is towards right? So hence the radius will be towards right. Yes or no? So u हो गया, v हो गया, r हो गया. We know the spherical surface formula, right? Mu2 upon v minus mu1 upon u is basically equals to mu2 minus mu1 upon r. So here v is known to you, u is known to you, mu1, the refractive index of the first medium is basically air, right? So this is 1. Yes or no? The refractive index, and the second medium you want to find out. So I think out of 5 variables, 4 are given to you. Fifth you can find. Yes or no? So mu upon plus 20 minus 1 upon minus infinity, which will be 0 ultimately. This will be equals to mu minus 1 divided by plus 10. So this will be mu by 20 is equals to mu minus 1 by 10. I think you people can solve it now. So mu is equals to twice of mu minus 2, and mu is equals to 2. And that's the answer. Easy. I told you, there are 5 variables involved. Please remember, out of these 5 variables, only one will be missing. We need to find out that missing one. Is it clear? Shall I give you next question?
Yes, sir.
There is a spherical boundary which is separating two medias. The refractive index over on this side is this much, and over here it is 3 by 2. Now the question is, a light ray is incident from an object. So find where. The question is, find where the radius is given 30 centimeter. The basically here is from here to here, the distance is 30 centimeter. Right? Find where an object O shall be placed in medium 1 so that light rays from O becomes parallel to optical axis after refraction. So basically, what do you want, guys? You want ki what is the value of u for which the refracted rays will become parallel to the optical axis. Is this clear? Try to analyze the data and try to give me the solution. अच्छा guys, एक थोड़ा सा people will generally get confused in what is mu2 and what is mu1, है ना? In the formula, please please please, ये मैं point बताना भूल गया आपको. People will generally get confused कि sir what is mu1 and what is mu2. So please remember, note one more point. You can write where you wrote the formula. No, please write note here. Mu2 is the refractive index of the medium containing the refracted rays, and mu1 is the medium containing the incident rays. Okay, can you do you remember this thing? Can you see over here? Mu1 is associated with object and object is associated with incident rays, right? So mu1 is basically the medium in which the incident rays are there, and mu2 is basically associated with V, and V is basically associated with image refractive index, refracted rays, right? So always remember mu2 is associated with refracted rays. Is it clear? इस पर मैं question दूंगा. I'll give you one question on this as well, है ना? Because I know people where they will get confused. So please write this point. है ना? Mu2 is the refractive index of the medium containing refracted rays, and mu1 is basically the refractive index of the medium containing the incident rays. Chale. So what has been given to you in the question? Sir, we need to find out what is the value of u for which the v. Tell me this particular thing. If the refracted rays are becoming parallel to the principal axis, where will the image form? Will it form at infinity?
Infinity.
And what is the radius of curvature? Plus 30, minus 30?
Plus 30.
Plus 30. What is the refractive index of the second medium? Mu2 कितना है?
3 by 2.
Mu2. Why did you say mu2 is 3 by 2? Can you see the refracted rays are in this medium? Right? So mu2 is 3 by 2, and similarly mu1 is
4 by 3.
4 by 3. So I think you people can apply it now. You know? Can you apply? Shall I leave this as a homework for you?
So will the answer be 80?
Will the answer be 80? Let me check. The answer will be 240. The answer will be 240. Some calculation error you might have done. So let me do it only. No problem. Mu2 is 3 by 2. V. V is infinity. So this whole thing will become 0. Minus mu1. Mu1 is how much? 4 by 3. And u is how much? Which we need to calculate. So don't put any sign with it. Although we know it's negative, but don't put any sign. Automatically sign will come in the answer. Mu2 minus mu1. So mu2 was 3 by 2 minus 4 by 3 divided by r, which is plus 30. So this is 0. Minus of 4 by 3 times of u, this is 4, is equals to 3 by 2 minus 4 by 3 is how much? Guys?
1 by 6.
1 by 6 into plus 30.
180.
1 by 6 plus 30. So can you see from here 3u will be equals to minus of 4 multiplied by 6 3s are 180, and this thing will be divided by 3 over here. can you see the answer is minus 240 centimeter? Okay, where did you make the error calculation?
Yes, sir.
Hmm. Chali, next question. There is a spherical dome. There is this spherical dome of I'll write radius. Figure shows a glass hemispherical spherical dome नहीं hemispherical है ना. The figure shows a glass hemisphere which is placed on a white horizontal sheet. So suppose there is a sheet at the background and it is, it's like this. Okay, so it's something like this. So it's placed on a white horizontal sheet. Now a vertical paraxial rays, is this the optical axis of the whole thing? Can you see this is the surface, right, from where the refraction will take place? Now the question is, if there is a vertical paraxial ray, please remember it is paraxial only, na? Control C, Control Z. So there is a vertical paraxial ray. Why am I not able to move it? So there is a vertical paraxial ray of a diameter D. It's cylindrical shape, right? It's in the shape of a cylinder and it is falling on a cylindrical surface like this, right? So what will happen? Refraction will take place through this particular surface. Yes or no? Guys, reflection will take place through this particular surface, right? Yes or no? And
Yes, sir.
after refraction, let us
Yes.
say this light ray will converge at some point over here. So can you see over here, guys? This light ray, let's say they converge at this particular point I. Now the question is, when these light rays will be converging due to this white sheet, what will happen? Will the light rays be able to go further in here? No, right? Due to this white sheet, they will not be able to go. But can you see over here at this particular point, the light will form a spot of diameter, let's say D dash. So now please see the question. Figure shows a glass hemisphere placed on a white horizontal sheet. A vertical paraxial beam of diameter D is incident on the curved surface of the hemisphere as shown. Find the diameter of the light spot. Find the diameter of the light spot formed on sheet after refraction. Okay, the refractive index of this is given as 3 by 2. Radius is not given. If radius is not given, then what will you do, guys? You will suppose it to be something and then start with the problem, right? Yes or no? Please start. I'm giving you 2 minutes and I'll be back by 2 minutes. You can discuss the question amongst yourself and come to a conclusion. We'll start. Chalo, okay, tata, bye. I am a 2 minute. And nobody discusses that. I told you to discuss the question among yourself and then karo, solve. I want the answers. See guys, the incident light rays on this spherical surface are parallel. So where is the object located?
Infinity.
Infinity. So u will be equals to what? Infinity. I have changed the whole convention. Can you see now the spherical surface is like this and optical axis is not horizontal. Optical axis is vertical. Right? This is the convention which I am using. So u is infinity plus infinity. And where is the image found? I do you know this distance from here to here? You don't know this distance, so v is not known to us.
Mm.
What is known to us now? Can you see the refracted rays are in which medium? Refracted rays are in this medium, right? Glass. Yes or no? So mu two, which was the medium of refracted rays, is basically 3/2. Mu one is air, and the radius of curvature is not given. So let's say the radius is r. If radius is r, then can you say this will be plus r? Oh, sorry, minus r. Can you say this thing? So this will be minus r. So now mu 2 by v minus mu 1 by u is equals to mu 2 minus mu 1 by r. So mu 2 is 3/2. Image, I don't know where. Mu 1 is 1. Image is object is at infinity. And mu 2 minus mu 1 is 3/2 minus 1 divided by r, which is minus r. Yes or no? So I think this will become 0. And this will be 3 by 2v is equals to minus 3 by minus 1 by 2r. Yes or no? 2 से 2 कटेगा. And can you see from here v will be equals to minus 3r. So can you see the sign automatically comes in the answer? So can you see
Yes, sir.
in the negative direction at a distance of 3r from the center, from the point where the refraction is taking place from the refracting surface, 3r distance from the image. Yes or no? But obviously this distance is smaller, this distance is bigger. Yes or no? So now you can see two triangles over here. I am drawing the rough diagram. This diameter was d. This distance is r where the image, where the sheet is placed, right? And let's say the diameter is d dash. This distance is 3r. So can you use the similarity of triangles? Yes or no? The radius will be in the same ratio of the sides. So you can say d dash by d will be equals to r upon 3r. And from here d dash is equals to, oh sorry, sorry, what do you want? My bad, my bad. This distance is 2r, right? So this triangle is similar to the bigger triangle. So basically this will be 2r. यानी से यहाँ से जो distance है यहाँ तक and यहाँ से जो distance है यहाँ तक, they will be in the same ratio as d dash is to d. So this will become, can you see radius gets cancelled and it will be twice of d by. Clear? थोड़ा सा tricky है but yeah, solvable. Last question on this and then we'll start with lens. What's the time now? 15:17. ठीक है, still time is left. Guys, last question on this, and then after this you'll leave one page, one full page. Are you done with this example, guys? So there is again a glassware of radius 10 centimeter, and from the center of this glass at a distance of 5 centimeter there is an object, right? This is a mu1, this is a mu2, and this is the principal axis or optical axis, whatever you want to say. Now the observer is over here. The observer is watching from this angle in the medium 2, right? Now the question is, figure shows a small object, let's name it object M. Its length is also given, but that's basically a question on longitudinal magnification, but wo abhi J NEET, we'll do later on this chapter. So uh, object M lying along a diametrical line of a glassware radius 10 centimeter and refractive index 3 by 2. Okay, so basically the value of refractive index is given to you, 3 by 2. This is air. Okay. Now the question is, find the location of object, sorry, image, या फिर मैं ऐसा भी लिख सकता हूँ, find the location of object as seen by the observer. So please remember, whenever I say it like this, now find the location of the object as seen by the observer, then the observer will not be able to see the object M because of this refracting surface, right? The observer will be able to see what? The image of this object. Is it clear? Is it clear, guys? Observer will be
Yes.
seeing what? The image of this object, not the this particular thing. Now, first of all, guys, uh, this is the सबसे पहले तो where is the image object located? Can you see the refraction is taking place from this surface? So all the distances will be measured from here. So the object is placed where?
15.
15 centimeter. Very good. Plus minus?
S-
Plus 15 centimeter. Where is the image formed? I don't know, sir. What is the refracted rays? The medium of the refracted rays. Is it 3 by 2 or is it 1?
By 2.
Huh?
1.
1 by
Because object is lying in mu1, yeah. So that
object से
means
मत
in
देख बेटा. Object does not matter कि where it is lying. See where this is the refracting surface. Yes, and see these are your incident rays. Always see with the help of incident rays. Don't see with the help of object. Okay.
so yeah. So from the object, incident ray will come here.
हाँ but अभी suppose ले मैं तेरे को virtual object का question देता हूँ. Suppose this is where the incident rays are coming, and let's say the object is over here. After refraction, the light ray goes like this, and let's say this is where the image is from. हाँ जी. अब can you tell me this? Up, can you tell me what will be the mu1 and mu2 in this case? Are you getting my point? Can you see object and image both are lying in the same medium? यहाँ पे confuse होगा?
Yes.
Are you
Okay.
getting?
This. Yeah. Yes, I get it.
हाँ. So that's why always see it with the help of incident rays and all. Don't see with
Okay, sir.
where the object is placed. Incident rays are in which medium? 3 by 2. Hence mu1 will be 3 by 2. And where are the refracted rays?
In
So this is 1. समझ में आया मेरी बात? And
Yes,
what will
sir.
be
Sir,
the
your
value of R?
M is your object.
Huh? M is the
Sir,
object, no? Yeah.
okay. It's inside the spherical thing.
Yes, it is.
Okay.
Radius R. Plus or minus?
Plus.
बस, अब बचा ही क्या है जीवन में. Okay. Is it clear? हो जाएगा क्वेश्चन है ना? Can I leave it to you guys? The final answer is plus 20 centimeter. So basically the image of this object forms over here, because all the distances are measured from here, right? Yes or no? Chali. Done. With this thing, I'm done with the refraction through curved surfaces and all. And I already told you to leave certain pages in reflection part as well. Leave only one page over here, guys. Okay? Leave only one page over here. Let's start with the lenses. First of all, please heading. Write down heading. Thin lens. And what is the lens basically? Thin lenses are basically lenses are basically regions which are bounded by two spherical surfaces. So the region which are bounded by two spherical surfaces are called as what? Lenses. Okay. There are two types of lens. First is the intersecting boundaries type lens, intersecting surface, and the second is the non-intersecting surface. So basically these type of lens, the two surfaces which we discussed over here, they will be intersecting, and here they will not be intersecting, right? Yes or no? So in the case of intersecting surface lens, suppose if I have this as one surface, and let's say this is our another sphere, right? Can you see this thing, these two guys? Can you see these two spheres? Can you see over here this particular surface and this particular surface is intersecting? So basically our material is only in this part. Okay, hello.
Yes, sir.
So basically
Yes,
these
sir.
type of lens are basically called as biconvex lens. The second type is basically what? Suppose if one sphere is there and another surface is plane. Plane is also a spherical surface, right? What is the radius of a plane surface?
Infinity.
Infinity. So this is basically a plano-convex lens. I'll tell you the reason why it is called as convex as well. Hai na? Third is like this. So can you see? This is a type, another type. This is called as a concavo-convex lens. So guys, first of all, why it is called as convex? I told you, no, convex is basically used for the term which is bulging out, right? So can you see in this case, both the surface were bulging out. So that's why biconvex lens. One surface is bulging out, one is plane, so hence plano-convex lens. And in the last case, one surface is caved inwards, and one surface is vexing up. So concavo convex lens. Is this clear? In these three types, what will happen? In these three type of lens, the surfaces are intersecting, right? Acha, there is one special case of this particular thing. If the radius of the two surfaces, let's say the radius of this is r1, radius of this is r2. If r1 and r2 are equal, and let's say it is r, so can you see the radius will become equal? So those type of lenses are called as equiconvex lens. Is this clear? Guys, क्या is clear है?
Yes, sir.
Here in this case, what is happening? R1 is infinity, one is infinity, and one is something, right? Similarly, in the case of non-intersecting surface, suppose if one lens is like this and another one is like this, so can you see, guys, the surfaces are not intersecting with each other. So these type of lens, if I fill material over here in which one spherical surface is like this and one spherical surface is like this, but these surfaces are not intersecting, so hence this will be a biconcave lens. Sir, why it is called as concave? Because can you see both the surfaces are caved inwards? Yes or no? If both the radiuses are equal, then it will be called as equiconcave lens. After this, if one surface is plane and another one is spherical, so can you see one surface is plane and one is basically having certain radius? So these type of lenses are, can you see again the two surfaces not intersected with each other? So this will be called as a plano concave lens. And the last one, one surface is like this and another surface is like this. Can you see, are these two surfaces intersecting with each other somewhere? No, right? This is called as a convexo concave lens. Can you see again one surface is concave and one surface is convex? Acha, sir, are you confused between this and this? Are they the same or are they different? Guys, are they same or are they different? Sir, one surface is concave, one surface is convex. They are same only, no? No, they're not. Here the surfaces are intersecting. Here they are not intersecting. There is a difference. Okay? Okay, people. So all the types of
Yes,
lenses
sir.
clear. Okay.
Yes, sir.
Okay. Now let's talk about converging and diverging behavior. Please remember the converging and diverging behavior of a lens depends upon two factors. One factor is basically the radius, the radii of the two surface, and the second factor is basically the surrounding media. Well, basically the refractive index of the two medium, the refractive medium of the lens and refractive medium of the surrounding, right? So suppose if I have this lens, this is a biconvex lens, this is, let's say, a plano convex lens, and this is basically a concavo convex lens, right? Yes or no, guys? These are your three types of lenses. Now, suppose if the medium surrounding is basically mu s and this is mu l, mu l, mu s, mu s, mu l, mu s, mu s. So suppose guys, if in the first case, if I say, let me make it a little bit down. If the medium of the lens is basically greater than, the refractive index of the lens is greater than that of the surrounding, that implies what? Lens is denser medium and surrounding media is rarer. Yes or no? Then all of these mirrors, all of these lenses will behave as what? Converging lenses. So basically the light ray which is coming parallel to it, they will converge at a point. The light rays which are coming parallel to it, they will converge at a point. The light rays which are coming parallel to it, they will converge at a point. Is this clear? Guys, is it clear? Abhi I'm behavior of I'm discussing convex lens. You know? First I'm discussing convex lenses, then I'll discuss convex lenses, concave lenses. Now case 2. If suppose guys, if this happens, that implies the lens is of a rarer medium and surrounding media is of a denser medium, then what will happen? What will happen? Acha, tell me what will happen if I reverse the polarity, what happens? Guys, in current electricity, if I reverse the polarity, what happens?
Current flows in the opposite
Current
direction.
flows in the opposite direction. Or can I say the behavior just reverses?
Yeah.
So इधर भी वही होता है. If the
Wait.
lens is having a rarer medium, suppose there is a air pocket
Hmm.
and air trapped in the form of a convex lens inside water, suppose. So this lens, even if its shape is of what? A convex lens, it will behave as what?
Concave lens.
Is it clear? Similarly, can you draw
Yes,
all
sir.
the others? Please remember these lenses are thin. So doesn't matter, sir, you are reflecting only from the first medium, first boundary. No, it's not necessary. I can, refract it from the middle as well, no problem. But since these lenses are thin only, then only I can draw this type. Otherwise, it will be technically wrong. Is it clear? And the last one as well. Is it clear, guys? Any doubt? Similarly, of concave lenses, that is what I am leaving as a homework for you. Obviously, concave lenses will behave just opposite of this, right? So these diagrams which I have drawn, they will come in that, and these diagrams will come in this. So again, two cases you will do and try to. हो जाएगा guys. You can leave half a page for this. एक बहुत ही इंपॉर्टेंट पॉइंट है ना, चलो विल डिस्कस दैट लेटर ऑन, नो प्रॉब्लम. Guys, let's discuss some points to remember. In the case of a lens, how many center of curvatures are there? Guys, hello guys. In case of lens, how many center of curvatures are there?
Two.
Two center of curvatures are there. So if there are two center of curvature, there are two radii and there are two focuses as well, right? There are, अरे यार, so there are two foci of a lens, right? Yes or no? Can anyone tell me all the different types of where the center will lie? Acha, let us take this left wala surface is 1 and right wala surface is 2. Can anyone tell me where will be the center of curvature of these two surfaces will lie? The center of curvature of this surface will lie over here and the center of curvature of this surface will lie over here, right? Yes or no? Yes or no? Similarly, if I have a planar convex, then suppose this side, then center will be at this side. So are you getting my point, guys? ये सब सबको पता है, don't draw it, है ना? In the case of plane, concave or convex and concave, so concave, they will lie on the same side, right? So we'll talk about it later, no problem. So there are two principal foci of lens. So always remember, out of these two foci, we define first definition is basically primary focus. Out of these two focus, one will be the primary focus and the other one will be the secondary focus. Guys, what is this primary focus? Guys, what will be this primary focus? Hello.
Yes, sir.
What?
It's the focus to the left of the lens. I know that sounds very fun, like
ऐसा कुछ नहीं है
rudimentary.
ना. It's not primary focus is towards left or the secondary focus is towards right. No, this is not the definition.
Okay, wait, can I try
Always,
again?
हाँ बिल्कुल try
If we
करो.
have a convex lens, and
हाँ,
so primary
the
focus is the point
I'll
at
give
which.
you a hint. I'll give you a hint.
Okay,
कि
okay.
you have whatever focus which you have learned in grade 10th, no, that's the primary
Hmm.
focus.
Okay.
That's a hint for you.
Yeah, I was gonna talk about the convex lens, concave lens, and say that that's where the image appears to converge from or diverge from. But I guess,
But अब तेरा right और left वाला convention तो गया फिर.
true.
Guys, can you find similarities in both these two diagrams? What is the similarity in these two diagrams which I have drawn?
The image appears to converge or
हाँ,
diverge
हट,
from the.
ये common है क्या?
primary-
Is this common?
No, no, no. The image is formed at the primary focus.
Obviously,
Be it real or
yes.
virtual.
I am drawing this in primary focus, so the image will be formed at primary focus. I already told you that this is the primary focus. But what is so common in both of them? Can you see, guys? Here the reflected rays are converging. Here the reflected rays are diverging. So are they common? No, right?
No,
The
yeah.
position of the focus is towards right. The position of focus is towards the left. Is this common? No. But can you see in both the cases the incident rays were parallel to the, अरे हाँ या ना?
So can you repeat?
In both the cases the incident rays were parallel to
The principal axis.
principal axis, so that is the common thing.
Oh, okay.
It is the
Hmm.
point of intersection of refracted rays when the incident rays are parallel to the principal axis. Is primary focus clear? And this primary focus is generally what we write it as f1, f2, f1. ऐसा technically we write, but it's not necessary, है ना? Generally people just know कि हाँ this is the primary focus and this is the secondary focus. Okay, so generally this focus is called as your primary focus. In spite of writing f1 to avoid confusion, let us write fp. Okay, is it clear, guys?
Yes.
Yes, sir.
Please draw the diagram very carefully. I'll try to define secondary focus for you. और ये थोड़ी tricky definition है. Secondary focus is basically tricky definition. Yeah, let me close the gate 2 minutes. I'll draw this diagram and then try to define it. Let me be back. गेट बंद करना तो आवाज़ें बहुत आ रही है. Yes, guys, anyone would like to try to define the secondary focus from the diagrams? Can you see the definitions will just get reversed? Primary
Hmm.
focus was basically the point of intersection of refracted rays when incident rays are parallel to the principal axis, and secondary focus will be it is the
Point at which the rays parallel to the principal axis originate
point
from
of
and travel
intersection
towards.
of incident rays
Okay.
for which the reflected rays will become.
Parallel to the principal axis.
So है कि नहीं principle of reversibility.
Hmm. Yes.
So this is your primary focus and this is your secondary focus. The one which you use in 10th grade F1, F2. So not only always F2 or F1 in the case of concave lens and F2 in the case of convex lens. Sir, that is not the primary focus. Primary focus and secondary focus are defined like this. बड़े हो गए. You have come in 12th grade now. You are not in 10th grade, right?
Yeah.
Anyways, always remember, note ka first point, I think the definition is clear, right? First point, there are two center of curvature, so there are two foci of lenses. Please remember, don't say like, sir, if the radius are different, the focuses will also be at different positions. No, that happens only in the case of equiconcave, equi lenses, equiconcave or equiconvex lenses, right? You are, if you say like, sir, if in lenses do we follow this relation, f is equals to r by 2, so technically if I say no, this is wrong in case of lenses. When you follow this, it's wrong. In 10th grade, I know everything was simple because your teacher didn't know anything. Or even if they know, they don't tell you people. Right? We try to keep it simple for people in 10th grade. But once you come in 12th grade, lot more technicalities are there. So, है ना? Is this clear?
Yes, sir.
Second point clear. Primary focus, secondary focus. Guys,
Yes, sir.
Yes, sir.
ठीक है. Now, C point. The distance of both primary and secondary focus. Mike, close the gate because people are shouting over there, and it's like I'm getting disturbed a lot. So the distance of both primary and secondary focus from the optical center of the lens. Do I need to give you definition on optical center? Is equal irrespective of the lens, right? So please remember, irrespective of lens. So basically, suppose if I have a biconvex lens, can you see the radius are different, obviously? And let's say, please, it is a thin lens, है ना? Please remember, it should always be a thin lens. So distance will be always measured from O. But can you see the distance between these two are different? But since it is assumed to be thin, so all the distances measured from the refracting surfaces are assumed to be measured from the optical center of the lens, right? I know lots of assumptions are there, but still. In this case, guys, both the focus f1 and f2 are at the same distance, and this length is called as the focal length, right? Even if the lens is like this, even if the lens is like this, still f2 and f1 are again at the same distances, which is equals to focal length. So don't think like, sir, iska radius is different, iska radius is different, so the focus of this will lie somewhere else and focus of this will lie somewhere else. No. Ye point clear hai kya? Are you
Yes, sir.
understanding what exactly I'm trying to say over here? It does not depend upon the surfaces where the focus is located. Focus ka formula hota hai, there is something called as the lens maker formula. Ab sir, in this case, can you see the curvature on both the side is in this side, right? C1 and C2. So you will say that both the focus will lie on this side. No, never. But 10th grade का logic 10th grade में use करने का है. Here also, both the surfaces, both the focus lies on both the sides, and always from the optical center. Is it clear? And same
Yes, sir.
similarly, concave lenses as well. Guys, is this point clear? Guys, acha. Still, there is one condition. Irrespective of the lens, provided the medium on both the sides of lens should be same. This is the only condition. If the medium on both sides of the lens is same, then what? Hello people. Then what? कोई बोलना चाहेगा? Anyone? Anything? If you would like to say something. If the medium over here is air and here also it is air, then this concept is valid. If this is water, this is also water, then this concept is valid. If this is glass and this is also glass, then this concept is valid. Are you getting my point?
Yes.
So irrespective of the material of the glass, if the medium on both the surfaces, on both the sides of the lens should be same, then this concept is valid. Is it clear? Sir, what will
Yes,
happen?
sir.
Which point is it? B point. If mediums are not same. Acha, please remember I'm talking only about the magnitude, right? Only about the magnitude. Obviously, you can see the sign will be different, right? According to the sign conventions. If the mediums are not, then ratio of focal length f1 is to f2 equals to mu1 is to mu2. So suppose you have any optical lens, any kind of lens it is, concave, biconcave, whatever. Suppose this is the primary focus f1, and let's say this is f2. If the medium over here is mu1 and if the medium over here is mu2, then this f1 and f2 will be different. And please remember, f1 by mu1, oh sorry, the one and the same thing only, is equals to mu1 by mu2. Now you got it, guys? Got it?
Yes, sir.
Chalo. Next heading, please write down. So I told you some points about these and all. So lens maker's formula. Please remember, in lens, f is equals to r by 2 is not valid. This is not valid. Your 10th grade teacher might have taught you like this, but no.
What?
In the case of length, f is equals to r by 2 is not valid. Even I was confused for a very long time. I was literally confused for a very long time.
So that's valid only for the mirror.
That's valid only for the mirror, and that too small ones. Okay, for paraxial incidences only. Anyways, I know 12th grade makes lots of surprises because 10th grade maybe
Yes.
don't teach you everything. No? That's fine.
So if the lens is having paraxial rays, then also it's not valid.
No, it also depends upon the refractive index of the medium.
Okay.
You
So
know this
no way
particular
it
thing.
can be valid
F
for
na
lens.
abhi next heading after lens make. Oh, sorry. Lol. So lens maker's formula. So abhi after lens maker's formula, we'll be discussing that only. The focal length. What will be the focal length in various cases, and then you'll actually get to know कि नहीं sir, focal length is not equals to r by 2 always. In the case of lens at least. है ना? In mirror it is there. Yes, no problem. And that is only for paraxial. So anyways, suppose guys I'm taking this as an example. I have taken a convex lens. It's a biconvex lens, right? Let's say the radius over here is r1 and radius over here is r2. And let's say I have this is the optical axis and I have an object which is at O, right? This is object distance is U, and let's say the image is formed somewhere over here. So this is where the image is formed. I'm not drawing the whole thing. Let's say this is like this is like this, and then this is like this. Okay, guys, can you see this particular thing? Let's say the medium which is outside is mu1. It is same on both the sides, and here inside the medium is mu2. Mu2 is basically the medium of lens, and mu1 is basically the medium of refractive index of medium of surrounding. And please remember, the surrounding should be same on both the sides of lens. Then only this lens maker formula is valid, otherwise no. Okay, lens maker's formula is only valid till the time the refractive index of the medium, or basically the surrounding, is same on both sides of the lens. Then only lens maker's formula is valid. Okay, so this is terms and conditions. Now can you see how many surfaces are there? दो surfaces है. Are there two different these surfaces? So for the first refraction, guys, for the first refraction, uh, can I write it like this? Ki object is over here, the incident ray goes like this, and let's say this is your refracted ray. If I try to produce this refracted ray in the forward direction, then the image, let's say, forms at I dash, and I dash is at a distance of V dash. So can I write this particular thing? Mu2 divided by V minus mu1 mu2 divided by V dash minus mu1 divided by U is equals to mu2 minus mu1 by R1. Can you see, guys? I'm not putting any sign convention over here. Why? Because from one formula I'm trying to derive another formula. Okay, इसका रीजन मैं कल दूंगा, आराम से, कोई दिक्कत नहीं है. और if you want I can continue the derivation tomorrow, or shall I finish this? कर दूं क्या finish? Guys, can you see for first refraction from this surface? Can you see for this surface the object is over here, and let's say the image is formed at I dash, which is at a distance of V dash. So the medium is basically lens. The medium of the image is basically what? The medium of the lens. Can you see the refracted rays? Who asked the question? Ovia? You said no, sir, object, and can't we take it like that? So can you see, it's not depend upon where the object is placed. Object or image can be in another medium only, no? But can you see the refracted rays from this optical instrument is in basically mu2 medium.
Okay, sir.
So that is why we have taken mu2, and the image was formed at V dash. So mu2 by V dash minus mu1 is basically where the object is placed. So mu1 by U is equals to mu2 minus mu1 by R1. R1 is the radius of the first refracting surface. Similarly, for second refraction, please remember now image I dash will be basically acting as your what? Image I dash will be acting as a virtual object for this image to get formed, right? So basically, the I'll try to draw this again. Thoda sa niche to make things a little bit more clear. This is the first surface. This is where the incident ray is, and this is where the reflected ray is. Okay, this is mu2, this is mu1, this is where the object was found, and let's say this is where the image I dash is found. For second refraction is basically this surface, right? This is the refractive index, this is the incident ray. For the second surface, this ray will become the incident ray. So basically this I dash will become a virtual object, and let's say it will get reflected like this. So this will be a refracted ray, and here, Here the I dash is formed. Guys, ये clear हो रहा है थोड़ा थोड़ा? Why have I used this particular thing? Right? And can you see for the second surface, the incident ray will be the one which was the refracted ray in the first case, and the refracted ray will be the what it will be coming out of the this thing. So for the second refraction, the incident rays are in medium number 2. So mu 2 divided by V dash. The refracted rays are in medium mu 1. So mu 1 divided by V is equals to mu 1 minus mu 2 by R2. Note, don't put sign conventions here because abhi formula I have not derived the formula, right? Because we are deriving a formula from existing formulas, right? We are deriving a from existing. This will help you in derivation, right? So don't put formulas over here. Now this is equation number 1, this is equation number 2, add them. So by 1 plus 2. Can you see mu 2 by v dash is in negative over here and mu 2 by v dash is positive over here, so it will get cancelled out and it will become mu 1 divided by v minus mu 1 divided by u is equals to mu 2 minus mu 1 by r1 plus mu 1 minus mu 2 by r2. Okay, so this equation gets formed. Can I take mu 1 common and this will be 1 by v minus 1 by u? This is equals to, can you see I can take mu 2 minus mu 1 common, so this will become 1 by r1, and can you see it was mu 1 minus mu 2, so hence minus 1 by r2, right? So 1 by v minus 1 by u is equals to mu 2 minus mu 1 by mu 1 into 1 by r1 minus 1 by r2. And what was 1 by v minus 1 by u? It was
1 by
1 by
f.
f from Lenz's formula. We'll derive Lenz formula as well. This is called as Lenz maker's formula. This is not Lenz formula. The Lenz formula is only this. Lenz maker is the complete one. Okay, please write this one. We'll discuss it in the next class a little bit more. And please remember, guys, now this is the formula. So hence use sign conventions when you use this formula. Is this clear? Don't use the
Yes,
sign
sir.
conventions while deriving this formula, because see, one sign convention you used when you derived the formula from single surface, right? The second time you'll use it over here, and the third time you'll use it in the numericals, right? So 3 बार हो गया ना? So it will get what? If it becomes 3 times, then automatically the answer will come wrong. Even number is fine, odd number is
Yeah.
not fine. Okay, so can you see here, by not putting the sign convention in the middle, I did what? The one formula which I derived was sign convention. That there is the first time I use the sign convention. The second time I'll be using directly over here in this formula, right? So that is why. Anyways,
Okay,
thank you
sir.
very much, guys. So that's it for today. Class थोड़ी सी ज़्यादा खिंच गई, but it's fine. If you have
So do
done
you have a
note,
minute? I just
हाँ
got a
बोलो.
doubt.
Yes, tell me.
It's in some mechanical